In our next problem, we have 3x squared e to the x plus x to the third e to the x equals 0. So we have x's all over the place. So let's get the ex's together. So we're going to factor out an ex from both terms. 3x squared plus x to the third all times e to the x equals 0. We also see that there's an x squared x to the third, so we can take out an x squared times 3 plus x times e to the x equals 0. So now we can separate and set all three items equal to 0. X squared equals 0, 3 plus x equals 0, and e to the x equals 0. So over here we have x equals 0. In the middle you have x equals -3. And this has no solution because e to the x is greater than 0. For all x's. So you only get two solutions, 0 and -3. So we're going to switch over to logarithmic equations. So our guidelines are to isolate the logarithmic term on one side of the equation. We might have them in expanded form and need to combine them into 1 first. Then we are going to write the equation in exponential form and then solve for the variable. So our first problem is ln of x equals 8. So we can just say that x equals e to the 8th. And we can plug that into a calculator and work it out. Let's work it out to 2,981. Our next problem, log base 2 of 25 minus x equals 3. Okay, so we're going to change this to exponential form. 2 to the third equals the 25 minus x. That goes to 8. Subtract the 25. So you have -17 equals a negative x, but we want a positive x. So x is 17. Now we have 4 plus 3 log 2x equals 16. So the x is inside the log, so we need to get rid of the outside stuff first. So we're going to subtract the 4. 3 log 2x equals 12. This 3 is multiplying the log, so it's going to divide to get it away. So that we are at log of 2x equals 4. So we're going to change it to exponential function. And there is no base written, so we know it's base 10. So 10 to the 4th equals 2x. We're going to take 10 to the 4th and then divide it by 2. And that goes down to 5,000 equals x. Now we have log of x plus 2 plus log of x minus 1 equals 1. So we're taking the logs of two terms and they're adding, so we're going to go from expanded form to one term. So it's the log of x plus 2 times x minus 1. This is log base 10 because there's nothing written, so we're going to change it to exponential form. 10 to the first equals at x plus 2 times x minus 1. That to the first power doesn't do anything. So we need to FOIL. You get x squared plus x minus 2 equals 10. Whenever you have an x squared as your highest term, it's degree 2. You need to set it equal to 0 so that you can solve for x. X squared plus x minus 12. We can factor that down into x plus 4 times minus 3. So we get our two solutions. X is negative 4 or 3. Okay, on these you need to go back and check. Plug it in. So we're going to check x to equal negative 4. So log of, back into the original, negative 4 plus 2 plus log of negative 4 minus 1. That goes down to log of negative 2 plus log of negative 5. This goes to undefined. If you try x equals 3, log of 3 plus 2 plus log of 3 minus 1 goes down to log of 5 plus log of 2. Now we can combine these into log of 5 times 2, and you get log of 10, which goes to 1. So x equals 3 is the solution. Negative 4 did not work. And we are about to interest. There's 3 different interest formulas. There's A equals R. That should be a P, I'm sorry. P times 1 plus R. That's your simple interest. Compounded interest is A of t equals P times 1 plus R over N to the NT. And A of t equals P e to the RT, which is the interest compounded continuously. So, we have a sum of $5,000 is invested at an interest rate of 9% per year. Find the time required for the money to double if the interest is compounded according to the following method. We have 2 different methods, semi-annually or continuously. So, the principal is $5,000. R is 9%, so we're going to change it to 0.09. t is unknown, but we know a of t, we want it to double. So 5,000 doubled is 10,000. So if we're compounding semi-annually, that means n equals 2, and we use the formula p times 1 plus r over n to the nt. So, this is part A, 10,000 equals 5,000 times 1 plus 0.09 over 2 to the 2t. So your first step is you're going to divide by 5,000. So we divide by 5,000. The left side will go down to 2. 2 equals, and let's combine a couple steps. 0.09 divided by 2 plus the 1 gives you 1.045 to the 2t. So we have t in our exponent spot. That means we need to take the log of both sides. So you get log of 2 equals 2t log of 1.045. So we need to get that t alone, isolated. Divide by 2 log 1.045. So you get t to be 7.702. So your money will double in 7.7 years if compounded semi-annually. If compounded continuously, we still have our principal of 5,000. Now e to the 0.09 t equals 10,000. Divide by 5,000. So e to the 0.09 t equals 2. T is in the exponent, so with e we want to take the ln, the natural log, because ln and e's cancel each other out, so you get 0.9 t equals ln of 2. So t equals ln of 2 over 0.09. So it takes you, oops, that should have been a 7.9 up here. This one is 7.702, not the last one. For semi-annual, it will be 7.9 years. For continuous, it is 7.7 years.